Can you hear me now? I think my mic was off. So I really hope you can hear me. Yeah, everything should be fine and set now. Okay, so we can start. It's 3 p.m. Welcome for this new episode of designing maps of science from scratch and using, doing it live here on Twitch. And the end goal is to produce open maps, with a license that allows anyone to use them, even for commercial purposes, and also to publish the documentation for these maps and the code and everything that facilitates reuse. The way I do that is by working 1 hour per week on the project. Actually, a bit more if that doesn't take too much time. But the principle is really to do everything live with you here. And the way you can actually trace the steps back to the previous sessions and find documentation is the Google Doc, which I use to just paste, useful links, and especially the links to the replays of these live sessions on YouTube. I think I'm a bit late on the replays. I'm like 2 episodes late. I'm gonna try and catch up. But let me paste the link to this document here. I think I had this nice shortcut. Does it work? Yeah, still. So this document, you will find everything about the past episodes. So for today, we're gonna do something which is not super glamorous, but super useful. We're gonna work on that. Let me show you. Okay, got it. So this is, I've collected about 20 million publications from OpenAlex by using a filter to diminish the number. The entire collection is maybe close to 300 million publications, so I just collected 20 million because it's enough for maps of science, I estimate. And the file, so I collected all of that in a file, not in a database, again, for the sake of making it easier to reproduce. No need to install a database. You just obtain a 65 gigabytes file. And so what we need today is to reduce this humongous file into something that is much easier to handle. So what you see on screen is not the 65 megabytes file, because it's on the server that I use to run the calls to the API, and that would take a bit of size on my local hard drive. So I just took a 10 giga sample from a previous aborted run. And from these 10 gigas, I've extracted, it's like not an extract, but it's like, I have a smaller sample of 18 megabytes. And this thing is useful to test what we need to do. So what do we need? What are we planning to do? Let me show you here. I'm going to just take some notes. So the way the works are written in the file are, you know, it's the JSON object for a work, comma, JSON object for a second work, comma. The way you can see it is really, it was done super simply. Let me show you here the way, you know, like JSON processor, like what do we do with the JSON we retrieve from OpenAlex? You know, you can see here, oops, you know, we just took the JSON of a given object, of a given work, we added a comma, and then we were just writing it to the disk, you know, to the file. So in the end, what we have is the file is made of that. And this is not exactly the structure of, it's not the proper syntax for a JSON file that can be read. A JSON file can be either I'm not a specialist, right, but I think it's just a single JSON object, or an array, a JSON array, an array of JSON objects. So what we need is something super simple. Oh, by the way, it ends with a comma. So that's our file, except that we have 20 million of these JSON objects, right? But we don't care. What we just need to add is, you know, an open bracket at the beginning, and then we need to suppress the last comma, and then we need to add a closing, oops, a closing bracket here. Yes, exactly. There is nothing easier than that, except that we need to do that on the file that is 65 gigabytes long. So I can't just open the file, open the, you know, add the open bracket at the beginning and do the same at the closing. The file doesn't fit in memory. So I have to do that using some coding operations that do not actually open the entire file, but just chunks of the file so that it fits in memory. So I used ChatGPT to code this thing that, you know, if you see here buffered, this thing opens the file using a buffer, then it adds the open bracket here. Let me do that, that's better. You know, in the output file, it starts by writing the open bracket, and then it writes the entirety of the file, and then when it arrives at the end, it should remove the comma at the end, and then it should write the closing bracket. So all looks fine, right? The only issue is that it doesn't work for some reason. This thing is, it removed the byte not at the end of the file, but at every buffer. Each time the buffer is renewed, it removes the last character. So how do I know that? Let me show you, because I did a test. Not this one. No, let me show you. Where was it? Yeah, this one here. Oh, what did I do? I removed everything. Oh no, okay, that's here. So it takes a bit of time just to open. So this is the thing that, oh, why is 3? that's the thing that's the result we are supposed to look for. It has added the opening bracket, fine. But then if you scroll down, so as you see, there is a syntax highlighter. It does recognize, like my text editor does recognize it as a JSON file. But if we continue scrolling down, a bit more actually, come on, quicker. Yeah, let me show you. At some point, it just stops recognizing the thing as a JSON file. And the reason is that the syntax becomes incorrect at this line. Actually, right there, there is a missing double bracket, double quotes, sorry. And I think that the reason is that it's improperly removed by that. So maybe what I should do today is, what I should do is just debug that. So I'm gonna just put a breakpoint here. And this thing should never be called except at the end, right? And what I suspect is that is going to be called several times. So let's try that. So I debug the file. I debugged, not the file, I debugged the program that, as I said, will add an opening bracket and remove the last comma and add a closing bracket. So the thing is running. It's still running. Takes a lot of time. Okay, never mind. Okay, and as you see, it hits the okay, so it seems to me that it's the end, right? Then let's see. So I click on continue running, and that's the end. So no, it seems to me it works as it should. So let's go to the file and see how it looks. So I'm opening it. I suppose it's processing. So let's look at the beginning. Do we have an opening bracket? So it has 3 opening brackets. What the I don't know, it's not supposed to do that. So I'm gonna, I think maybe, I don't know, what's the thing here? I should remove result. Yeah, just to make sure I don't make any silly mistake, I should remove the result file before starting writing in it, just to make sure I don't concatenate the results of 2 runs. Okay, let's do that again. Okay, the program has run. I'm gonna open it. It has 3 opening brackets. What's the problem here? So my code is really crappy. You see output right? It's supposed to just create 1. Why does it create 3 opening brackets? Maybe that in the origin maybe that we have 3 opening brackets actually there in the, you know, in the input file actually. So all works JSON. Yeah, I suppose that must be that. Let's wait. Yeah, it has 2. Why? Okay, so my oh, I hate that. My input file, the file I'm using for test, is just not good. So I'm gonna remove. I suppose I made some tests that were, you know, writing on top of each other. So I'm gonna just, you know, manually fix the JSON file that I'm using for my tests. Shouldn't take long. Come on. Okay, there. So fixed. Just added the missing double quote. Oh, and it starts again. Oh, shoot. Okay, it doesn't work. Too many things to fix there. I'm not going to be patient enough. What should I do? Why did I mess up? Okay, so I'm going to try it on the 10 gigabyte file. But how can I? It's going to be, no, I have to, no, sorry, I really have to. 10 gigabytes, then I can't open it in a file editor because it's too big, so I can't really evaluate the result of my operations. So I have to work on this small file. It's just that it has a number of incorrect things that I just introduced. But I fear that there are a lot of issues, not just a couple. Okay, I'm going to do something else. What I'm going to do is, as you see, I have this sample works. Which is super simple. It's like one it's one work, so one JSON object, and I repeated it. I just copy pasted it a couple of times to, yeah, got it, it's here. I just copy pasted it a couple of times to create a kind of test file with just a few JSON objects in it. And I was hesitating using it because I thought it could be too small, you know, if it has to be bigger than my buffer size. I could just reduce the buffer size actually, that would work. So what I'm doing here is just trying to introduce line breaks between objects so that it's easier for me to navigate. Okay, so done. Look at that. Oops. I have three, you know, line number one is an object. line number 2 is an object, and the two objects are separated by a comma. And line number 3 is an object too. Oh, you don't see it, sorry. Up is an object too, and it's separated from the previous one by a comma. What I'm going to do is copy this last object with the comma, and as you see, it has a comma at the end, right? So I'm going to just paste that a couple of times. Copy, paste, or paste, 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 paste. Okay, so I have 30 objects. I hope it's above the buffer size. And now I'm gonna just run my code, so not on all works, but on, so by the way, all works, I'm gonna remove this one because it's corrupted. I made some, and this one I'm gonna, that's this one. This one I remove. Yeah. So all works.json. All works.json. And the result should be all works result.json. Okay, so now I have a good test bench. Just to repeat, I'm just trying to do something super simple. I'm just, let's remove these things, they don't exist anymore. What I'm trying to do is simply to and I have a file that looks like that, except that it's super big. And I just need to introduce an opening bracket there. Sorry, it has an ending. I need to remove the last comma and to add a closing bracket. And I don't want to do that on the file that is 65 gigabytes right from the start. It's much easier to try and do that on a test file. So I have just now with you created this test file, which is there. So as you see, it doesn't start with an opening bracket. So my goal is to get this opening bracket. And if we scroll to the end, it's finishing with an, oh, you don't see it, sorry. It's there. It ends up with a comma, and I would like this comma to be removed and replaced with a closing bracket. That's it. And when I'm sure I can do that, I'm going to run the same program on the huge 65 gigabyte file. So let's run this test. And it seems like, you know, I'm struggling a lot for something super simple, but actually what I'm doing is I'm learning a very useful skill, which is the skill that consists in working with huge files that don't fit in memory. So in this case, it's for really something simple, but once I get the logic of it, I can then apply it to more complex cases. Okay, so the test has run. I'm going to open the result and see if what I need has been achieved. So yoo-hoo, you see an opening bracket there. Now what I like to see is, did I break the, no, fine. Oh, shoot, okay, it has added a closing bracket, but it has not removed the comma before, which means the JSON is still not properly formatted. So I just need to think, right? What did I do? Oh, I suppose you have I suppose that in the entry file, let's look at the original file. You see, it doesn't end with a comma, it ends with a line break, actually. So maybe I introduced that, because in practice, let's look at the way it's going to be written. So I'm going back to the JSON queue processor, whatever, you know, the thing that writes the JSON file. And we should be fine, because actually it does end with a comma. You know, there is no line break added anywhere. So it means that my test file should be exactly the same. It should be that, you know, comma, no line break after the comma. Okay, so the test file is correct now, so I can run again the test. Run. Finished. Let's look at the result. Look at that. Perfect. Oh, you don't see it. It's here. It's somewhere. So first, let's look at the. Okay, you see, we do have this opening bracket, but we knew that from before. And let's look at the end. Oops, oops, oops. What? Oh no, yeah, I'm not on the correct file. See, all fine. The comma has been removed, and the closing bracket has been added. So the test file works. Now let's do that on the file which is much bigger, which is the one which I called partial. Actually, it's a big chunk, right? It's 10 gigas. So let's do our little trick on this one and see how long it takes. I'm just curious, you know, is it going to take a minute or is it going to take minutes or seconds? Probably more than seconds. Where am I? No, I was there. So this time we're going to do this is our file, and I would like to measure the time. So I have this utility class that I've created, and if you are a Java coder, please have a look at my utility class, because it doesn't have a lot of useful stuff, but there is one thing, which is this clock, which is just a nice way to clock your operations without any difficulty. Okay, so we're gonna have the exact, oh, you couldn't see it, sorry. We're gonna see the exact duration. So if you couldn't see, I just added a line at the beginning that says that it should start measuring the, you know, the time of the following operations, and then when the operations are finished, it should print the time that elapsed since the start. Okay, ladies and gentlemen, let's see how long it will take to process it's just reading and writing 10 gigas of text file and adding one character at the beginning, removing a character at the end, and adding a character at the end. Run. And I hope we will have no memory issues, but we shouldn't since the, oh, let me check. So general, this is the clock that has started. I called it general. If you just look here, you know, that's the name of the clock. So the operations have started. I would bet on 20 seconds. 10 gigas, yeah, maybe more. I don't know. "46 seconds. That's brilliant. So it means that for the real file, the one that's 65 gigabytes long, we should expect a couple of minutes. I wonder if that can be increased by increasing the buffer size. Sorry, you know, optimization is something which should be relegated to, but I love optimizing stuff. So buffer size. What is the optimal buffer size in Java, which is badly, that's, okay, multiples. How do we determine the ideal buffer size when using file? So it's not file input stream that I'm using, but so let's look at the I'm just curious, right? It's not something I should spend time on, but what if we double the buffer size? Do we speed up the operations? Let's try that. So I've doubled the buffer size, which means that at each, it means that the file is cut in bigger chunks, twice as big. Run. So we were at 46 seconds. Let's see if it's like markedly quicker or not. I would bet on 30 seconds. "35 seconds, so quicker than like 10 seconds quicker. Okay, good enough. Okay, the buffer size has an influence. So that's all fine. And now, so by the way, congratulations, we have made a great, you know, that's nice to be able to read a 10 gigas file without opening it, without loading it in memory. So now let's move on to the next issue for today, which is we have a properly formatted JSON file. What we want to do with it is, and that's really nice, we want to basically to filter out all the attributes and keys of this JSON file, except for a couple of interesting ones. So that's how a file looks like, except that, of course, it's bigger, but... So we want to keep only the author IDs. And I would be super tempted to keep not the entire ID. Sorry, you don't see everything here. Okay, so in the file has, as you see, a lot of information. For the sake of creating maps of science, we need just the ID of the journal and the authors who published in this journal. And an author can be a name, an affiliation, a display name. We don't care. We just want actually that for each author of a given publication. And for the journal, that's the same. So the journal information is around there. What we want is not everything, we just want the ID, which is this thing. So as you see, this huge amount of text for a given work can be reduced to the list of author IDs and one ID for the primary source. That's it. Yeah. So should I, my question, what I'm thinking is, should I actually have this intermediary step where I strip the JSON file of everything unnecessary, and then I work on this slim JSON file? Or do I immediately parse this big JSON file and extract from it what I need? Namely, for each work, I need the ID of the primary source and the IDs of the authors. Well, I think that's what I want to do. Okay, let's do that. So the way you do that on a file which is again too big to open in memory is you use a library that reads a JSON file without loading the JSON file in its entirety. So for that you have libraries. So the json library is the most famous one in Java, but I prefer to use the one that from the Jakarta, the Eclipse Foundation, because Eclipse is kind of a very central organization developing Java, so I tend to trust them a lot. I just need a tutorial or something. Come on, I just want I think that's the correct thing here. Yeah. Okay, so I've never used that, but we gotta work on it. Okay, so I'm gonna create a new class called JSON parser, JSON streaming parser. Creating a method which is gonna do like parse journal IDs and author IDs. It's gonna take as an argument the address of the file that we are parsing. And it's gonna do things. So I'm gonna just add a main method here. I can't add a main method. I can't remember the shortcut. So I'm gonna do the public static void main that many Java students, I suppose, hated, as I did in the days. Okay, so what do we want? We want to parse this file using a streamer. Oh, I think I have added, so I've already added the dependency for, yeah, nice. So it's Eclipse Parson that provides this library to parse JSON in as a stream. So the question is, how do I go from I don't know, maybe that it's not a string reader. So what does it accept? What does it accept? Input stream. Okay, so let's do that. I'm not a specialist of these things. New file input stream, I suppose. Oh, seems to be the correct way to do it. Fantastic. Well, we'll see in due time, right? I'm not saying that's exactly. Okay, so we don't want to count. I mean, this thing was just, you know, so there is the notion of event. I don't know what an event is. We'll see. Okay, we have different types of events. Oh! So we start with an array. Okay, fine. Okay, that's super simple actually. Okay, super simple. Okay, so what we want is author. Wow, okay. Okay, that's a bit, okay, I see. So when we see author as a key, we should wait for the next key, which is ID. Wow, okay. That's boring, but... So each time you find the author key, don't do all these things. That was just for the sake of the tutorial, but we are doing something different. It reminds me of the XML parser from a long time ago. Okay, if you do that, okay, that's okay. So I need some flags. Author started. I hate this. Okay, how much time do we have left? So if we find an author, then we are entering a JSON object of an author. So, okay. Okay, I think we should do something like that. That's a bit better. So if author started, exactly, I hope you see what I'm hinting. If we are in an author, so basically if we are, you know, yeah, I think that's the key. Then take the ID. Yeah, so basically, that's not the issue here. How do I get the... Oh, that's complicated. Let's go back to the... What does it say? Oh, that's complicated. I think I get it. I think that with JSON next, we are moving to the value. I'm not sure. Ah, exactly. Oof. Okay, I get it, I think. I think it's getString simply. That should get us the value of this ID. Value of ID, I think it's that. But I can just give it a try. So do I make a mistake? Of course I probably, but okay, let's see. I would expect the value of ID to have the proper ID of the author. Da, 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 da. We'll see. So I expect it to be called next to be value string. Yeah, as you see, value string. So that should contain, no. Oh, because for some reason it bugged or something. What's the issue here? What went wrong? Okay, something was something is not working here, so let's try it again. Yeah, it works. Brilliant. So I do capture the ID of the author. Fine. Okay, so all good. As I said, I would prefer to have not the entire value, but only the last part, the one where we have just that. So it's after the last forward slash. So I'm just gonna add a little helper method here. Keep only or remove URL from ID. Oh, that's gonna be... So I would like to have a result. So all so the result is actually, it's not a JSON file, it's a text file, and it's come on, Clément, it's journal and authors pair work. Oh, by the way, 4, that's boring, but I should have the same as the JSON queue processor, basically. I should have something that keeps writing. Yeah, I'm gonna do that later. Okay, but at the moment we have the value of ID, of author ID, by the way. I would like to remove or keep, we're gonna keep last part of ID, that's gonna be the name of this method. So somewhere we have a string builder, I don't know if I can, I've never tried. Can I insert something at the beginning of a string builder? If I append? Insert, yeah, maybe. I suppose that's going to be insert. Okay, fine. Okay, so and we add that to the string builder. And we append a comma to it. And then, how do we know we have left an author? Well, we know we have left an author once we have finished reading the author ID. So I can say author started equals false. And then it's going to get the next author, all fine. Okay, and then for the journal's ID, it has to be primary location and source. Pretty simple. No. Sometimes the copy pasting doesn't work well in NetBeans. This is a famous bug. As you see, it's really simple once you get the logic for the author's ID. You do the same for the journal ID. The only difference is that we don't I would like to insert it at the beginning of the string. Oh yes, it's so gonna Java insert string at beginning of string builder. Yeah, exactly what I need. Yeah, super simple, okay. Okay, this way I'm collecting the journal ID and the author IDs of a given work. And I multiply that by 20 million works. Pretty neat. And then I should offload that. Oh, I should, by the way. I should append a line break. And I should close. No, that's fine. So let's try that. Let's try that for, well, how I can try that. Yeah, I could try that on this small file, but first I have to create it. Okay, so let's create this small file. This small test file. Run. So I'm just creating a text file of a couple of works, which we see here, 100 kilobytes, so super small. And now I can test it on here. I'm just gonna write the result. Oh, come on. What's the issue here? Okay, so once, by the way, yeah, everything should be fine. Okay, so let's try that. Go. What's the name of the result? Journal and authors per work. Okay, go. And if we're good, then we're finished for today. Okay, no error, which is fantastic. Journal and authors per work. Let's open it. Ooh, not exactly what I expected. Close to it. Oh yes, of course, makes no sense. Okay, yes, of course, absolutely. Okay, I need two string builders. So string builder total and string builder temp. So as soon as I find an author, I open a new string builder. And this is the string builder I'm using. Okay, I think that's better. Let's try that again. No, I made a mistake, I think. yeah, I did make a mistake again. Yeah, I'm not even gonna look at the result. I know it's a mistake. No, don't want to look at, basically it's not when it finds author, it's when it finds authorships. Then it should create a new. Yeah, exactly. So let's try again. Might cause a mistake. No, fine. Ta-da! Look at that. Perfect. The first ID is the journal. Then you have a pipe. And then you have the list of authors that published this work in this journal. I would love to remove the remaining comma just for the sake of being nice. The thing is, I hate removing the last Java remove last character of string builder. I hate doing that. Okay, exactly that. So now if we run it again, we should get rid of the last comma of each line. Exactly. Okay, fine. So we did what we wanted for today. First, reading a multi-gigabyte file in order to fix some formatting issues. Namely, adding some opening bracket and adding some closing brackets to make it a properly JSON formatted file. So that took us half of the session, and then for the second half we had a JSON file that was properly formatted, so we could parse it with some code. So that's what we did, and what we did was simply to, in this huge JSON file, to pick only, so each JSON object is an article, and what we just did is, among all the information you have on the journal article, we picked only the name of the journal where the work was published and the name of the authors, you know, the people who authored the publication, and we have written that in a file where each line is a journal article. The first part, you know, before the pipe, it's the single identifier of the journal where the article was published, and after the pipe you have a comma separated list of the identifiers of the authors. So in this file each line is the same because it's a dummy file. Each publication is the same actually. So, but you see that we are super close to what actually matters. If we have a list of journals and a list of authors who published in these journals, we're going to be very soon be able to compute similarities. Are two journals alike? Yes, if many authors published in the two, many similar authors or identical authors published in the two journals. And we are very close to having the data cleaned in a way that will allow us to do these comparisons and computations. The only thing we have to do next week is that I can't run that, what we just did, on a huge file, because we are accumulating a string, and once we have finished, we are writing the string in a file. So that's fine when the string is relatively short. But if the string becomes huge, then we won't have enough memory to hold the string in memory. So what we're gonna do next week is this boring thing where, yeah, that's what you see here, where we don't hold the string forever until we are finished and then we write it. We actually keep writing the string as at regular intervals to offload it from memory. So that's what we did when we did the API calls, and we're gonna have to do the same now. And hopefully we're gonna be closer to the interesting point of computing similarities. So thank you for following so far. And yeah, I'm gonna post all of these streams in replay so that, and I'm gonna chapter them so that we can get to each bit as necessary. And I'm gonna also, of course, push the code on GitHub so that you can reuse it. Thanks again for being here, and see you next week.